So we will continue now with a shorter exercise, which is here. The import of another sheet metal file that is not really BricsCAD sheet metal yet, but you will see how easy it is to change it into BricsCAD sheet metal and to even adjust the features of this element. So let me grab back my drawing. Okay, so what we will do now is we will go to, you need to make sure that the folder 11, I think, folder 11 is downloaded and you know where it's located, so that you have the SLDPRT file and you can import it. So you can choose, you can first launch a new drawing in the mechanical millimeter. Then we can import the SLDPRT file. So that being said, we can start importing. Nothing special, just pressing the import button. And, okay. So yes, then we have this imported element. Now this isn't sheet metal yet, so we select the entire solid. Remember, toggle between faces and solids with the control tab, depending on what you have prioritized. One or the other will be control. And then you can convert to sheet metal. At least maybe, yeah, okay, that's the next step indeed. And then we see that the entire element turns blue and yellow for the bands. That's always a good check, is the visual check. Are all my parts colored blue? And are all my bands colored yellow? Are all my junctions colored orange? Because that's a check to see if your part is a good sheet metal, let's say, but more on that later. And if we check the mechanical browser, you actually see that while creating this, converting this to sheet metal, all the flanges were actually even detected. The bends were detected, but even more than that, the forms were detected. So the form features here, they were all detected. But on the other hand, they are a bit maybe too detailed. They are not parametric, so I cannot select them. And if I know which one I'm selecting right now. Yeah, this one, for example, I cannot select it. I don't see the parameters because it's not parametric yet. But what we can do is change, change the replace. That was the word I was looking for. Replace the import, like the general features, with some features that we created in BricsCAD itself, which are parametric. So how do we do that? We hover over a face of the feature, and we choose this feature replace option. So it's the blue to the gray feature icon. And then we click that one. And now we will be asked to navigate to the correct folder, or actually, yeah, you will be taken to the form feature category of the sheet metal design library if you look closely. So you can stay into that one. Not sure, but I think it's also delivered together with your with the training exercises. So you can also find it in the training exercises and choose the louver there. So I don't know which one was chosen here, but I think it's from the built-in library here. So, but whenever you would not find it easily in the built-in library, maybe you can just use the one that was delivered with the training. And then you just press open. And then you see a very important prompt, which is asking you whether all the similar features should be replaced. And we want to press yes, so that we only have to do this step once. And then it's loading. And you will see that all these louvers have been replaced, also on the other side, with parametric ones. So whenever we now select the louver, or I don't know, I'm not sure how to pronounce it, you will see that the length is changeable. So let's see, it's that one there. So if we change the length to 40 or something instead of 35, you should see it change. Oh, wait, I did something wrong, I think, and didn't accept it. Probably.
Fleur, there is a problem. Please expand the louver feature and click on yes inside. Yes.
Okay. Okay, so
I already reported it.
Okay, great. So yeah, now you see a change. Thanks, Ilya, for the notion. So if anyone encounters the same issue, that's how you solve it. So just click instead of the overall parameters here that apparently are not adaptable right now in V21.1.6 that I'm using right now. You can press the plus button in front of it and change the parameters there. So I will now change it back because it doesn't look nice if they're not all the similar size. And then the holes, we can do the same, like the embossed parts with the hole in it. We can do actually the same with those. So we can hover over a face of it. We can use now in the quad, it will be the first option. So we can use that one, and we choose emboss with hole, and we open that one. And we can again press yes to change all similar inserts. And then you see it changed again with a parametric part. Also the bottom looks very nice. And then we will draw a line on the bottom here. It can be a little bit tricky to draw this line if your eSnap is on, because it will snap to certain locations, maybe not on this face. So what I do to be sure is I turn off my eSnap and I launch the line command. And then I shift lock the face again, just to be absolutely sure I'm working in this face. And then it doesn't really matter where, but you can start your line and you can choose it a certain length or give it a certain length, for example, 150, and draw orthogonally with shift and then press enter. And then you will be able to draw a new line, but we don't need that. So just press enter again to exit it. And then you will have a line of 150 millimeters at the bottom. And now we can actually change this into a rip feature by going in the sheet metal tab again of the quad. So remember, you can pop it up also by right clicking in empty space, and you can create a rip feature. And then you will see, if you look at the bottom, it will be a bump, or how do you say that? And here it will be an indent. And you can again also choose this rip and see the properties. So you can play with the properties here. The radius is now used a global value, but if you use an absolute value, you can change it to whatever value you like it to be. So for example, instead of having this radius of the indent to be 1.2 or something to be 5. And then similarly, you can also, for the rounding here, You can choose how long it should be. It's just, you can play around with this a bit. So for example, 3, then you will have a bigger rounding, like you can see now, right now. And as such, you can play with the rib feature. And then the last part is unfolding. So again, make sure that everything is blue, or yeah, dark blue for the features, and yellow for the bands. If not, you can still select the entire solid and click convert to sheet metal again, and then it will redo the conversion to sheet metal so that it is proper sheet metal. So I select, for example, the bottom face, and then I can see the unfolding, click enter to keep it. And then you see the rib is annotated, this is annotated, good. Here we have a slow bend, so it gives you more lines. And here the form feature, the louvers. So that's it for this part. And then we have still a very small exercise of sheet metal assembly export, which is pretty cool. And that's with the last part here, which is sheet metal assembly export. So you will have the out folder already there as well, apparently. And then you have here the definition. So we or yeah, the, how do you say that? The, I don't know, the assembly just. It's not sheet metal yet. You can see it that it's not blue. So you just have an assembly of a top part, a component, a bottom part, some pillars, and so on. And now we can actually export this as a sheet metal assembly. And what it will do is it will convert it. It will try to convert it to sheet metal, and even export it to 2D. Yeah, so that you can immediately manufacture it. And it will also give you a report. So we can call the SM assembly export. I'm not 100% sure where it is in the ribbon, but yeah, you can always type in the command. Oh yeah, and I should save it first, apparently, just because I edited some things. So here, then it's asking you what you want to export as sheet metal. We will just try the entire model. And then normally it will ask me a folder, I thought. Probably because I already, yeah, I should have selected the output dialog, because now I don't know where it will put it. We'll put it probably straight into this folder where it was located. So yeah, let me show you again the first part. So assembly export. So SM assembly export. Okay, and then before you hit entire model, you should choose the output folder, because now it will be all in my general tab, and it's better to keep it all in one clean folder, because otherwise you get a lot of folders in this exercise folder. So you get a lot of things, but yeah, doesn't matter too much right now. I already have it, so I can go to the 24/7 folder on my computer, where you either have a subfolder, or if you accidentally pressed accept right away, it will be just sitting in the folder altogether. So here in the export, you see that now, before I only had the turn style, and here now I have also some pictures and a report. The report HTML is an interesting one to look at. So if you open it up in a browser, you will see that some parts are converted to sheet metal with the status OK. So they were automatically converted. And then here you also have one that says poor sheet metal. This one is not entirely correct yet, so we should take a look at it. You can even open the DWG as a copy from here. And then, yeah, you have some bars that are also the convert to sheet metal is failed because, yeah, they don't have a fixed distance because they are circular elements, so they are classified as not sheet metal. But let us go to the top assembly. This is just to show you. It's not needed to achieve this in this training, but I want to show you. So I will, here you have now all the parts of the assembly that are converted into sheet metal separately, and they are called, for example, top assembly is one of the parts in the assembly, and that's the top of the assembly. And you see it's not converted into sheet metal, while the bottom left, for example, should be converted right away to sheet metal. So I think at least, oh no, it's a 3D solid. I'm not 100% sure, maybe because of my output folder, I did something wrong. But in any case, this is not sheet metal, and I think I did something wrong because last time it was blue already, right? Yes, it was blue already. So I will just retry by making a separate output folder because I think otherwise it might not work properly. I'm not sure. Someone of the other colleagues of mine will wants to answer this, but I think something went wrong. And so I will make a new folder, or if you have the out folder, it's in place, you can also locate it there, and I will select this folder and I will do entire model. Yes. Okay. So you should have something which is already halfly converted to sheet metal with the top assembly normally.
Hi, Fleur.
Yes. Mm-hmm.
You will still need to convert the top assembly to a sheet metal component.
Okay, because okay, yeah, I see. I skipped that step. Sorry. Yeah. Okay.
No
so
worries.
It's because it failed. It didn't convert it automatically, right? That's the case. Or... Okay, but in any case, now it's nicely put in an out folder. Okay, cool. Top assembly. So yeah, since it wasn't able to convert it itself, I need to convert it manually. And then you can apply junctions to the entire model. So again, press junction, but instead of now selecting certain junctions yourself, you do the entire model. And then you will need to still apply some junctions to here, the radii that are a little bit big. So I will do that manually. And then you see it can split them, but the automatic mode doesn't detect them yet. So I just do that separately.
Just so you know, I believe you have to apply bends to the entire model first.
Okay then. Sorry.
And then you can apply junctions.
Yes, I see. Yeah, and that's because otherwise they will of course not be connected to each other. Thanks, Frederick, for that. Okay, so bend to the no, not to that one. Sorry, I accidentally clicked already. So to the entire model, bend first, yeah, and then you see some edges were skipped, but some of these edges will be able to convert to junctions automatically, and then some you will have to add manually. So then I do junction, and then you can see that also this gets split just as this one. And then also in the back, because if there is one hard edge left, I think the unfolding will not be able to unfold, because a hard edge is a bit impossible in sheet metal. So now we have a lot of bends, a lot of junctions. We can escape the junction creation, and now you can see where you can unfold it. So you select one of the faces and you choose to unfold the body from this face. Well, it doesn't actually matter, but which face you choose. But, and then, yeah, it worked. So you see that even these complex shapes, they are perfectly unfoldable. And that's it. If I needed to explain something more, Frederick, you can still help me out. Otherwise, it's time for the breakout rooms. They will be shorter, just for you to mainly try the feature exercise. And yeah, if you have time, the assembly export can be interesting as well.
Now, in these 2 days of the mechanical training, I hope you have gained a better understanding on how to navigate and operate the mechanical product. Throughout the training, we have been working with fairly small models and assemblies, but of course, the knowledge you have gained here is also applicable for larger projects, such as this escalator assembly that you should see on my screen. Of course, this example is a bit more advanced than what we have been doing, but I think you will have a better understanding of how everything works now. And in the end, no matter how many parts exist here, similar principles are used. For example, with the help of direct modeling, inserting parts, constraining them together, you can see here the constraints of this, as well as underlying constraints and parameters, which we have covered in the training. So as you can see in the mechanical browser, what might have been a bit overwhelming a few days ago, maybe and hopefully you have a better understanding of the structure at this point. Entire assemblies like this also, you can generate a bill of materials like we have done previously, where you can see all the different parts here. The same thing that we did earlier with adding a total sum of the quantity and the mass is still applicable. We can also here make this assembly parametric, although of course it is more advanced than what we have done. It is still something here you can see what is possible with some of the knowledge that you have gained in the sessions. For example, now I can then, with the underlying parameters and constraints and the ones existing on the top level, I can then change up the model with the existing parameters. And like previously, the bill of materials will still update to reflect any changes and such. Of course, in this training, we did not get to cover everything that the mechanical software offers. Such as suppression groups. For example, you can have suppression groups to control the visibility of certain parts, or you can use the suppression groups to create levels of detail for your assemblies, for example, to improve the processing power and such. As well as with this sub-assembly of the escalator with smaller parts, as you can see, or less parts. We can also create things such as exploded views. That can be placed in drawings as well, and we can also animate these things. And we can also create animations of it. as well as some certain features that have been released in the V21 version of BricsCAD, such as the piping library and more extensive sheet metal features. But perhaps there will be room for this in the future. So with this, it concludes the mechanical training sessions. I think I speak for everyone in the team here when I say it was an enjoyable experience. I really hope you think so as well. All the recordings of the main sessions will be available in Bricsys 24/7 in about a week's time, I believe, together with the datasets and guides. So thank you everyone for attending, and goodbye.